Welcome all the guests who join us online today. I'm your host, Amanda. It's my pleasure to have all of you to visit our 5G AIoT Experience and Experiment Base in Taichung. It has been a new norm to have these online activities and webinar in the pandemic to now endemic. Yet, I can assure you of having total experience and great content from this virtual walkthrough. Before we begin, I would like to briefly introduce Digiwin software and our 5G AIoT EEB. Digiwin software is a leading industry-specific solution and software provider in Greater China and Southeast Asia. Without a doubt, digital transformation is a must-do to achieve Industry 4.0. You might be familiar with ERP, NES, shop floor control system, etc., while we can provide all these top-notch products and consulting services. With the help of digital tools, manufacturers can improve their management capabilities and overall competitiveness. Manufacturing process is long to go. Orders, materials, production, inventory to shipment. Each stage is crucial and cannot be ignored. As a business owner, IT software can help you to collect data in real time and accelerate decision-making process. However, we are facing a problem of shorthanded in the whole world. Meanwhile, operation technology, OT, can help you with daily routine tasks to make good use of human resources. The staff can spend their time on more complex work. Digiwin software has extensive experience in manufacturing software for various industries, and now we have gathered a group of automation equipment specialists to collaborate and implement in-depth integration of IT and OT, and gradually achieve intellectualization. The 4 key points to smart manufacturing are high on-site visibility, resilient scheduling, good OEE score, and effective logistic management. Meanwhile, IT plus OT can help you with all the above. Seeing is believing. The establishment of our 5G AIoT EEB allows manufacturers to witness the operation of automation and other technological equipment on site. The real-time dashboard in a war room, intelligent warehouse logistics system, automated truck loading system, AI applications, and up to 18 solutions for you to explore and experience. Are you excited to have a look at our EEB? Let's cut to the chase. Hi Chewy! So we have Chewy here today to bring us on a complete virtual walkthrough. Can you please introduce yourself to the guests online?
Thanks, Amanda. Hello, everyone. My name is Chewy. I'm very happy to take on this role today. I also hope that I can give you a simple concept of intelligent manufacturing.
Thanks, Chewy, for your time today. I have done some research before this, but I still have some questions in mind. I bet you can help me with the answer. We know that digitalization is necessary, and most of our clients and the guests online have started to work on it. But OT is another thing. So how do we start, or let's say integrate from IT to OT?
Okay, of course, the digitalization is an important step in intelligent manufacturing. But the digitalization is not a thing. It's a lot of things. It includes the data visualization, data transparency, data predictability, and the data adaptation. It also needs to connect all the devices by IoT technology, complete all the data for the system to learn, so-called AI, step by step to achieve the intelligent manufacturing in your enterprise.
Got it. So it shall be an implementation in stages, right? As I mentioned at the very beginning, this is the correct path to improve the management capabilities and overall competitiveness. So especially in this new norm that we are short of human resources and cannot visit a site. In general, we would say robot, but there's more than that. We couldn't deny that we must rely on technology in the future, but sometimes I wonder, how does a future operating model look like? Chewy, can you please show us in our demo area?
Yes, that's came with me. Today, in this area, I will introduce 2 common scenarios, digital employee management and AR remote assistant, to show you the future operating model of the enterprise, the data-driven scenario. First, let me show you about the digital employees. In terms of the factory management, managers use emails, verbal inquiries, or phone calls to show about production and the information, so as to make the decision. but it is slow and non-real time to update data through this method in the factory. It may take half or a day to get this data, and the data needs to organize after collect. The key data extraction and analysis is used to decision making. That we call the big data analysis and the data application. Through the implement of the digital system, we can achieve the real-time feedback of manufacturing data with the manufacturing data application and the manufacturing information. It can drive and help manager make decisions and judgment through the digital employee. Now, I will demonstrate the digital employee assistant manager in making management decisions. Okay, the digital employee is here. Please show the status of the machines in the factory.
Okay. The oven temperature on sizing machine number 2 is too low. The qualifying range is 155 degrees to 170 degrees, and it is currently 141. In this case, the yield rate may be lower than 60%.
Let me check the details of the sizing machine number 2.
Okay. The equipment control system has switched to the parameter status of sizing machine number 2.
Please give me follow-up advice.
According to the historical data, 2 options are provided for you to optimize the operation. The first option is to adjust the oven temperature from 158 degrees to 162 degrees. The second option is to adjust the temperature of the slurry tank from 32 degrees to 35 degrees, and the yield rate is expected to improve.
Return to the main page.
It has switched to the main page. Do you need any assistance?
No thanks.
Wow, that's really convenient. It's just like an upgraded series specified for manufacturers. However, what if the digital employee just told me about an abnormal production? Can I request repair work remotely?
Sure. Let me introduce another intelligent tool. Okay, I will show you the scene whether a person needs assistance on production side. He or she will get the remote assistance through the AR HoloLens. For instance, such as equipment failure or abnormal production, personnel cannot prefer the maintenance and the repair through the existing production site information. In the moment, it is necessary to ask the original factory or the headquarters personnel for assistance. So, when will remote assistance be needed? What's the difference between the making video calls with our mobile phone? Okay, we were in an AR HoloLens. First of all, a typical case is that the factory may have a dangerous condition, such as a chemical factory, or a site has movement restriction, like working at height. Engineer cannot come in. Now, the maintenance can be operated by AR HoloLens that the abnormal location can be identified, and it can be repaired with both hands without holding the phone all the time. In the following, I will show you how HoloLens provide assistance. Let's see here. The HoloLens system is queued in the back end, in the remote assistant. You will see the screen on the AR HoloLens. In remote assistance, the system will hold a video conference. All remote assistants will be recorded and built an abnormal knowledge base. At the same time, the abnormal location can be marked, explained through HoloLens. Like this situation. So that the maintenance and the repair standardization. The maintenance guide can be presented through AR HoloLens. Under the COVID-19, it can shorten the communication time between maintenance engineer and the original dealers, as well as the communication cost is reduced.
AI and AR are definitely changing the world by making the impossible possible. So what can we do in long term? Other guests online would like to know about the long-term roadmap to intelligent factory. Chewy, do you have any example to give a more clear explanation?
Okay. Let's go to move the machining area. This film is about the machinery industrial, which is commonly known as the manufacturing enterprise with tooling machine like CNC. The CNC means the computer numerical control machine, like the milling machine, lens, grinder, casting, etc., etc. We can see here. Let me introduce the integration scene of IT plus OT. It's to drive intelligent machinery with intelligent manufacturing. We want to transfer from event-driven to data-driven. First of all, please look at the case of the Howell Industrial. A factory is guided by the Digiwin professional consultant.
Because of the small quantity and variety of models and a short delivery time, the frequency of production line changes is quite high. Once the equipment has abnormal problems, it can only be handled by experienced workers. However, the number of masters and time is limited, and the production site personnel cannot deal with it promptly. Hence, there are a lot of inestimable waste costs. Through the in-depth integration of IT plus OT, the three major capabilities of Howell Industrial digitization, networking, and intelligentization are improved. We can make the distance between the production site and decision-making closer by data-driven management. At the production site, there are two main factors that affect the machining accuracy: temperature and vibration. Therefore, a type of 10-gram sensor for pressure, temperature, and vibration is installed on each machine in Howell Industrial production site. Using these sensors to record machine vibration, temperature, humidity, flow rate, pH value, concentration, speed, pressure, liquid level, and other application technology data. Through the key drainage products, 5G FR1 independent networking, and 5G FR2 plus 4G dual-mode non-independent networking structure, data transfer to the cloud fast via edge computing server and Core Pro platform. Through data collection and timing reports, the tooling accuracy and equipment availability are improved. The health indicators of the machine can be grasped at any time. Howell Industrial has built a comprehensive data collection to digitize, standardize, and transparentize the production process. In addition to reducing the tasks of people operating the machine, it can also make the production site status completely visible so that the decision-making is valid. After collecting the data, the next step is to think about how to integrate this data into management through the network cloud to enhance the company's intelligent manufacturing capability. When the equipment issues an abnormal alarm, the system will immediately notify the production supervisor. They can find out the problem and troubleshooting to the machines. Once the machine is confirmed to be faulty, it will be shut down and notified for maintenance. The production manager must check the capacity of other machines in advance and reassign the work orders of the failed machines to the other machines to ensure that the production tasks in the day can be completed. If the machine is overloaded in the day due to the adjustment of production tasks, the production manager will reschedule tasks to prevent the equipment from affecting the order delivery due to the unexpected conditions. Recording through 5G and network cameras to monitor the production process of real-time operating of the machine and perform image backtracking of the production process when there is an abnormality in the production materials. When the equipment is shut down for maintenance, humanoid detection is performed on the surrounding area of the machine to prevent workers from entering dangerous areas. Applying the face recognition and real-time body temperature measurement, in addition to recording the entry and exit of the production site personnel and body temperature records, the attendance system is also integrated so that the production manager can grasp the status of each production site personnel clearly. Howell Industrial built a digital layout of production management through daily operation, production, abnormality, and troubleshooting. IT and OT data have been accumulated and iterative optimization and become the company's exclusive data center. Companies can use this basis for short, medium, and long-term project improvements to improve their overall competitiveness continuously. Data application will become the most experienced technician at Howell Industrial, from digitization to networking and intelligentization. The deep integration of industrial software and equipment to build up the intelligent factory with high efficiency and flexibility becomes a powerful core for corporate operation and improve the accuracy and immediacy of decision making. IT plus OT integration and innovation makes Howell Industrial move towards digital transformation. In the next step, Howell Industrial will have more opportunities to become a value creator, develop new business models, and achieve the long-term strategy with the goal of sustainable development of the company.
From the video, we can see how Howell Industrial has changed from visualization to intelligence. After the intelligentization, we can see that the manufacturing side is controllable and manageable, and it can get three benefits: quality, cost, and delivery date. In order to improve the management visibility, the production planning and scheduling, the equipment availability, and enhancing the poor production ability. So how to transfer from the visualization to the integration of IT and OT step by step? The first step is machinery data collection, which is also called IIoT, Industrial Internet of Things. Nowadays, Industrial 4.0 has been run at least 7 or 8 years. It is not an issue whether the machine can be connected or not. Moreover, the main issue is how do we want to connect and what application of this data should be done. That is the key issue that the enterprise needs to pay attention to know. Most of tools and equipment in the past 10 years can be integrated through the OPC UA or the Ethernet IP. The machinery data can be transferred from the controller to the edge server through the network interface. The machinery data such as the machine status, tooling quantity, and the tooling runtime. Other equipment that does not have the communication capabilities, such as customized machines and traditional machines, like drilling and boring machine, or need to additional collect data not provided by the machine itself. It can also be imported by sensors. Data such as rotation speed of spindle and the least square information are collected through the data acquisition unit, or the IoT gateway, and then feedback to the edge server or device cloud. For what? For data analysis with integration of manufacturing data. Based on the analyzed data at the data center, the equipment on production side can be arranged in the best way, and the application data further combined with domain knowledge. Calculated and driven in MES. MES is a manufacturing execution system. If you hear the MES, they should be talking about work order management, scheduling work order, tracking OEE, and tracking the process. And the OEE is the overall equipment efficiency, it's the AQP, right? Availability, quality, and performance. We can explain OEE in more detail later. Okay, so at the high level in MES, in the MES build, the whole picture of the data will become a three-step process: data visualization, data identification, and data driven. The visualized production data feedback is only the first stage. We can find out the abnormal and give the early warning with this data. The enterprise needs to pay attention is the next action showing real-time feedback data after the abnormality occurs. The next step for equipment alarm, from the traditional time-based maintenance management to the condition-based preventive management. Let's take a look at the common theme in the factory. When the equipment alarms, what should we do next? Let's imagine a scene in the machining factory. When the equipment alarms, abnormal notification and the data collection will be performed, and begin to maintenance. The preview factory will stop at this step. However, we can do the data analysis in the next step. The data analysis is carried out from two perspectives. The first is tiny report the remaining machining time of the key workpiece. The second is abnormal data collection. The equipment capacity and the state information are sent back to the MES and the device cloud management center. The equipment availability rate based on the real-time production site information. It drives the best equipment maintenance schedule, the best process planning without interruption of production, and it generates batches of the maintenance order at the same time. That requires the personnel to carry out maintenance and reporting. This is show you how to utilize the association and the binding of the manufacturing data to drive the next actions, instead of only driving events such as the maintenance with equipment alone. Furthermore, we can do the production adjustment through the data association, production rearrangement with the machine maintenance, real-time production rearrange after the maintenance is complete. At the same time, we can update the standard labor time and the production progress of the machine on the day, and remove the overloaded process task to rearrange the progress of the next day. The above introduced show that's how the enterprise should process the roadmap of the intelligent factory and which benefit will be obtained after the implementation. And next, I will introduce you to the theme of the exhibition area. In addition to the roadmap of the intelligent factory, our exhibition area are included and combat information centers or so-called war room, intelligent storage and transportation, and automation line in central. Next, I will mainly explain the above three exhibition areas.
It's great to learn from successful companies to reflect on what we can do next. So I have seen the production dashboard constantly updating the numbers and data. I bet this is the simulation of the war room, right? If I were a business owner, I would like to monitor the production site anytime, anywhere. The staff might report the concerns and condition weekly or monthly, but the data is not on time and the problem might worsen. So what can we do with visualization? I shall leave the time to you, Chewy.
Okay. Actually, the data planning design of the digital dashboard is need to think about. The dashboard is not just for looking fancy, right? More important is which information we can get from this dashboard and help us to make decisions. Therefore, the design of the dashboard is usually presented in different dimensions. One dashboard for one functional dimension and one dashboard for each production workshop. So you will see that there will be many dashboards in the war room, and the different positions will have their own data needs. Let's take a look at this major dashboard from the perspective of the business operator and the production manager. The major indicator he or she needs to know are the delivery rate of the orders and the daily capacity or weekly capacity. And from the perspective of the factory supervisor, the entire factory information will be focused on three data: the goals to be achieved, the abnormal to be removed, and the current state of the exception handling. If there is more critical data on dashboard, we can use gesture sensing to notice the cause of it. For example, the real-time data of OEE. When the efficiency is low, we can switch to see which of three measures in dedicated cause the efficiency down. Utilization time, utilization performance, and yield. Then find out whether the equipment is abnormal and the reason for this. We can adjust immediately to reduce the waste of the production cost. Okay, and about the multinational production factories, we can control the factory in Taiwan, Malaysia through the gesture switching. It is applied to the headquarter design and the global manufacturing. Next, let's see these two dashboards that analyze the factory data with different dimensions. For example, in this production time period, the manufacturing data is feedback and analysis by hours. We can know whether the quantity per hour meets the standard, whether the work orders per hour are produced smoothly. Under the overall monitoring hours, like the 8 hours a day, the production supervisor have 8 decision-making opportunity a day to carry out manufacturing deployment. Thereby, the concept of lean management is implemented. Next, let's look at the production schedule dashboard. This dashboard based on the sales order, work orders, and the production information for decision making in the production and the sales meeting. Under the index of the order delivery, we can perform limited capacity scheduling. Okay, let's check out this one. In terms of the factory management, active image recognition technology can be used for real-time management. This screen is demonstrated with the concept of the digital fence. When the automation line is active on the holidays, there is no one in factory at least 12 hours, 48 hours, or 16 hours. The issue of the factory safety can be solved through the visual identification solution. For example, if someone enters the operation area, a warning will pop out. Two judgment factors are used to determine whether it is a person or not, and whether she enters the forbidden area. If these two factors are met, the data will be sent back immediately. The system will perform the next process actions, such as issue a sound warning, or shutting down the equipment or the robot in time.
Thanks, Chewy, for the detailed information. And here comes my favorite part, moving robots. Let's move to the area. Please forgive my foolishness, but this is indeed the most remarkable to help with the manufacturer in logistics. In machining industry, the goods may be heavy and difficult to move around. With the precise information fed to the system, voila, robots can help with the manual work. I shall leave the time to the expert. Here you go, Chewy.
Next, I will show you the IT plus OT scene in the intelligent factory. Under the management of Digiwin MES and the intelligent logistics, the intelligent machines such as AGV and the robots are driven. There are three themes including warehousing, logistics, and machining. First, generally in machinery industry, the storage side needs to manage the incoming and outgoing goods, storage position, and the materials return. The material storage type roughly divided into box storage, pallet storage, and bar storage. Under the data association of storage location and materials, we can perform warehousing optimization and the inventory analysis. Under the integration of the intelligent warehousing, intelligent logistics, and AGV, the design of storage space will be more efficient. The warehousing area will be smaller than the previous design, thereby reducing the production cost and amortized by warehousing land. After the warehousing and the material input, the next part is very important, but this one may easier be overlooked by factory. This is waiting time between the release of the work order and the production of the machine. This waiting time is an invisible cost waste of the factory, and also a common production bottleneck in the machinery industry, which also known as effective tooling time. The effective tooling time of a 20-hour factory is about 40 to 16 hours. The company does not know why the effective tooling time cannot be increased, and the reason for the suspension. Under the implementation of the Digiwin intelligent logistics, the information flow between the warehouse and the production side is linked and associated. When work order is issued, the intelligent logistics immediately corresponding to the material and its storage location. AGV starts the material picking task by RMS, the robot moving system. The RMS prefers optimal planning based on the path from the storage location to the production site. It shortens the time from the work order issue to the material arrive. Hence, the logistic data of the factory is visualized. Now, please look at this operation. After the work order is issued, the ERP will send transportation task to the RMS, and the AGV starts picking materials. The logistics between the material outbound from this warehouse and the inbound to the production site is carried out perfectly, and the unmanned storage and the transportation is realized. Okay, we take out this workpiece. The AGV will return to the warehouse.
Automation brings convenience to the manufacturing industry. Besides humanless storage and transportation, I saw a giant robot arm over there. Shall we take a look?
Sure.
Wow. You might wonder if we can accomplish a full production line with automation. Yes, we can. Chewy, can you please let us know how does this work?
Now we are in the machining side, the processing scene of the CNC milling machine. After the AGV finished transportation, the workpiece combined with the quick mold changing system. The robot automatically loads the workpiece and start tooling. With the implementation of intelligent manufacturing system, we can achieve the goal of fully auto production line with the combination of IT and OT, thereby reducing manpower and the technical threshold. Next, let me show you the scene of the automation line. Let's look at this one. The dashboard is applied for this automation line. When we start tooling, the system will collect real-time production data during the operation, including tooling time, waiting time of transport, and the waiting time of loader and unloader. More importantly, it's able to monitor the effective operation of equipment with the OEE. Please follow me. When the workpiece is arrived, the tooling task is triggered. And the system tightly enforces the robot to carry out a feeding operation. The waiting time for feeding and the loading is recorded and feedback to the system for real-time OEE calculation. And you will see the dynamic OEE is shown on dashboard. After the tooling complete, the system records the overall processing cycle, the time of workpiece unloader and returning. In the digitalized factory, in terms of OEE calculation, it has achieved real-time calculation and monitoring. we can immediately start production adjustment based on the OEE data. For example, if the OEE is lower than 15%, an early warning will be issued. If it is lower than 30%, a notification will be made, and the improvement must be carried out immediately. This is the theme of the digital factory with the visualized production data. That is why the physical factory becomes the virtual digital model. The flow of the physical process will be reflected in the digital factory. The domain knowledge will be integrated to the applications such as the predictive diagnosis, resulting in the production improvement and the production life management, etc. This is the term you may hear in the field of the intelligent manufacturing, the digital twin.
I have so much input today, Chewy. Thank you for walking us through the main stations of our 5G AIoT EEB. Due to the time limit, we couldn't show all of our equipment, tool, and technology here today. But we welcome anyone who is interested to know more to contact us. Please scan the QR code beside to request an appointment. Our experts such as Chewy will provide more information in regards to IT, OT, or IT plus OT solutions. If the situation allows, please give us an actual visit to explore all of this on site. Once again, thank you Chewy and other guests online. I hope you loved today's virtual walkthrough. I'm Amanda.
I'm Chewy.
And I'm looking forward to seeing you again.
Bye-bye.